Low accelerated algebra 2. Stir up here again. This is notes for 11b, adding and subtraction rational expressions. So it's a way of saying we're going to be adding and subtracting fractions. So start out pretty simple. Back the old school way, and I know I've shown you the butterfly method, but what you would do is you'd have to make sure you had a common denominator. So that would give you 3 plus 4 on top over 6, which gives you 7 over 6. So just leave that as is. Second one, you'd add multiply by 2 and by 2. So you'd get 6 plus 6 over 8, because the bottom would become 8 now, which is 12 over 8. And then you could reduce, oops, sorry about that, 12 over 8, reduce that to 3 over 2. And then this one I can multiply by 2 and 2, this by 3 and 3. So it's going to give me 4 plus 9 on top, and it's all going to be over 30, which is 13 over 30. I guess if we stop there, most of you would be like, cool, I got this all day long, right? But nah, it's math. We got to keep going. So we have to make sure we have like denominators, add and subtract the top. So the numerators, remember, is top. Place the result over a common denominator, which is the bottom. Simplify the results as needed. So see if it'll factor or cancel out. Okay, problem number 1. We have the same denominator, agreed? So I'm just going to add the two tops. So I'm going to get 9 over 3x. And then you can go ahead and say, you know what, 3 goes into 9 3 times. So I wind up with an answer of just 3 over x. Something I want to show you on these. When it's subtraction, change that to a plus sign and make this the negative. This will be easier for you in the long run. I know it seems a little obscure right now. So on top, it's going to give me 2x minus 4. And on bottom, I get x plus 3. X plus 3 is factored all the way out. I would like you to go ahead and factor out the top too. So you're going to get this. And if you start this practice, you're going to start seeing binomials eventually start canceling each other out. So this is a really great correct answer on that problem. Again, the big key is changing the subtraction sign, making it an addition sign, and just moving it up. And we'll continue that practice. Pretty simple. So 3 and 2 added together gives me that. And then I can go ahead and say, you know what, 1 goes in there, 1 goes in there. So I wind up with 1 over x. Make sure you keep, if everything cancels on top, you keep a placeholder of 1. All right, so add and subtract rational expressions. Same ideas. Okay, we're going to walk through these. Okay, so we're not doing anything here. We just want to know what the least common denominator is. Well, all I'm going to do is just look at the two denominators. So I have this one and I have this one. This one is factored, x minus 1. This one is not. That becomes x plus 1 and x minus 1. If I were to add these two fractions together, I have to have this as my denominator on both. Okay. Next problem. I'm just going to take a look at the bottom. So this is going to factor to x plus 2 and x minus 1. This one doesn't factor at all. So if we were to add or subtract these, we would have to have the same denominators. So x plus 2 and x minus 1 would have to be my denominator of both of those fractions in order for us to be able to add or subtract these. Now we have 3 terms. Okay, so let's do this first. I know that that would break down to this. This one stays as is. And then the last one, I have 2, and then x plus 1 and x plus 1. Okay, so we want the smallest denominator they both have, all 3 have. So a 2 is definitely part of the equation. A singleton x, I would definitely have that as part of the equation. And then I have an x plus 1. But being I have the second one here, I have to have that. This would have to be my denominator if I were to add or subtract those fractions all together. All right, so let's go ahead and do this. So in order for x to look like 3x squared, I have to multiply this by a 3 and an x and a 3 and an x. So on top, I'm going to get 15x over 3x squared plus 2 over 3x squared. Notice my denominators are the same, so I'm going to go ahead and combine the top. Well, 15x will not add to 2, so I'm just going to leave it at that. That's actually factored. I'll put in parentheses, and then it's going to be over 3x squared. Problem's done. The next one, I want my denominator to be 2x squared. That's my common denominator. So I'm going to have to multiply this by x squared and x squared. I'm going to have to multiply this one by 2 and x. Remember, we'll do both top and bottom. And I have to do this by 2 and 2. So the first one I get 1x squared, which is just x squared. And then the next one I'm going to get plus 4x minus 6. Okay. Let's see. Well, the top factors of 6, 2 and 3, 1 and 6. Nope, that won't work. That is a factored answer. That is as far as we can get. Okay, next problem. We should recognize that that is the difference of 2 squares, so x squared, or x plus 2 and x minus 2. This means that my common denominator is going to be x plus 2 and x minus 2. So I have both fractions have to have that same denominator. The first one already has it. Ooh, we have that negative sign there. So I'm going to put the negative right there. Now I'm going to make that a positive sign. So what else do I need to do this problem to get that same denominator? Well, I have to multiply this by x minus 2 on bottom and x minus 2 on top. Okay, so on top I have the 4x. This negative 3 has to come here and here. So negative 3x and then plus 6. Notice the signs changed. So if I'm going to combine like terms on top, 4x minus 3x is x plus 6. That doesn't factor any further. And I have x plus 2, x minus 2 on bottom. And that is our answer. Problem number 10, this is factored and this is factored. So I need both of those to be my denominator. So I have x plus 5 and x plus 1. That's going to be my denominator. So I need to multiply this one by x plus 1 and x plus 1 on bottom. And then for this one, I need to multiply by x plus 5 and x plus 5. So I want to make that a plus sign and make that negative right there. So on top, we're going to distribute here and here. So I get 3x plus 3. And here I want to distribute the negative 4 here and here. That's minus 4x minus 20. And then go ahead and do the math. 3x minus 4x is minus 1x, or just minus x. And then minus 17, because 3 minus 20 is negative 17. And then I have x plus 5 and x plus 1. Now, I'm almost positive this answer is going to be fine, but a lot of times we don't like having a negative out front. So a lot of times we would want you to factor a negative 1 out and change the sign. Is this one that I'm writing right here a better answer? Sometimes, especially if it's multiple choice, and which most of the rest of our tests will be. So that would be what we'd have factored out. Problem number 11, we want to go ahead and factor out the bottom. And so I'm going to have x plus 5 and x minus 6. So I already have my common denominator, x plus 5 and x minus 6. So I'm going to multiply, that's already factored. Make that a plus, make that a minus. Multiply top and bottom by x minus 6. Okay, so on top I have x by itself. Distribute the negative 1 over that, so I get minus x plus 6. And so combine like terms, x minus x, those cancel, so I get 6 over x plus 5, x minus 6. And there's our answer. Now we have 3 denominators. Now, I will tell you, friends, a lot of times when we have 3, if I were to FOIL this and this together, I would get the third thing, which I indeed do get. Okay, so my common denominator is going to be x minus 1 and x plus 6. And that's what that factors out to. Okay, so first one I'm going to have to multiply, put that in parentheses, and multiply by x plus 6 over x plus 6. And I can FOIL that out, so that's going to give me x squared plus 8x plus 12. And we'll worry about like terms later. We have a subtraction sign, so I'm going to make that a plus and make that a minus. I'm going to multiply both top and bottom here by x minus 1 and x minus 1. So distribute the negative 2 over both of those. And then the last one, we have this. I'd make that a plus, make that a minus, so I don't have to do anything to that one, so I'm just going to bring that minus 14. Let's combine any like terms we can on top. So x squared stays as is. 8x minus 2x is 6x minus 2. And that doesn't appear to factor, so we're good leaving it like that. And we have this as our and bottom. Now sometimes when something won't factor all the way out when you're dealing with these, you put it in parentheses, and that kind of might give you a little bit of a hint that, hey, that won't factor any further, so you don't need extra work, you know, if you have to walk away from the problem and you came back to it later. Okay. Ooh, 3 terms. Let's see. This is going to be x plus 3 and x plus 3. This one will be x plus 3 and x minus 3. And then that just stays as x minus 3. So my common denominator here is going to be x plus 3, x plus 3, and x minus 3. So notice, because I had 2 of these, I want to write it twice, and I only one of those, and that's the same as that. So if I go to here and say, all right, what do I have to multiply this first one by? Well, I'll put that in parentheses. I'm going to multiply this by x minus 3 and x minus 3. And I can FOIL that out, so that's going to give me 2x squared. What is that going to be? Minus 6, so minus 1x minus 15. In the second problem, I'm going to want to multiply by another x plus 3 and an x plus 3, top and bottom. So I'm going to distribute that over, so that gives me plus x squared plus 3x. And then the last one, I need to multiply by x plus 3, x plus 3, and x plus 3, and x plus 3. I have to multiply that twice. So if I go 1 over that and just FOIL that out, that's going to give me plus x squared plus 6x plus 9. And now we're going to look to see if we have any like terms. So I have 2x squared, and x squared. So I happen to have 4x squared there. Minus x plus 3, that's plus 2. Plus 6, that's plus 8x. Then negative 15, positive 9 is going to give me negative 6. And that's going to be x plus 3, x plus 3, and x minus 3 is my denominator. The only thing I left on this one is I might think that you would want to factor out a 2 from both all of those and see if the inside will factor from there. And so with that factor, that's going to give me a negative 6. Nope, that's not going to factor, but I have broken it all the way down. That might be a spot where if this was a pencil and paper test, you would miss 1 point by not pulling out that 3 or that 2 out front. All right, now we get to something called the complex fraction. So don't let these scare you. Best way to do a complex fraction is you do what's on top and then you do what's on bottom. And then you worry about the rest as you move on. So I'm going to change this to 8 over 8. 1 is the same as 8 over 8. And then I can add those together, so that's going to give me 11 over 8. And I'm going to change this to 2 over 1, so that's going to become 4 over 2. So 4 minus 1 is going to be 3 over 2. And now you have 11 over 8 times 2 over 3. And we can cancel top to bottom now. So 1 times 11 is 11. 4 times 3 is 12. So I get 11 over 12. Next problem. Remember, that's going to be over 2. Again, remember you do the top part first, and then you do the bottom part next. So that's 2 over 1, which is going to give me 8 over 4. 8 over 4 is 2. Then 8 minus 3 is 5, so I get 5 over 4. And then on bottom, make that over 1. So I need to make the denominator 3, so that's going to become 9 over 3. 9 over 3 is the same thing as 3. 9 plus 2 is 11. 11 over 3. So I get 5 over 4 times 3 over 11. It doesn't look like anything's going to cancel, so I get 15 over 44 for an answer. And that's it. So the homework is going to be 11B. Pick any or all to try them out. We can do a Zoom lesson. And just so you know that 11A and 11B homework is all together, and I'll have it labeled on Schoology. But let me know if you want to do a Zoom. Okay, I've been setting up quite a few meetings on Zoom, so keep checking those emails. Make sure they're there. Have a great day, everyone. Take care of one another.